So, after my first video in Pursuit of Antigravity Part 1, I got a visit from the men in black sedans and helicopters who informed me that I must never make a Part 2. Okay, so that's not entirely true, although I'm pretty confident I'm already on a number of government watch lists, but I haven't scored a bingo yet. At least, not that I know of. However, after posting that video, I did have an old friend get intrigued by the research. Now, like many of you guys, he too had fooled around with these lifters 20 or 30 years ago. And at that time, he just concluded, like so many of us did, that the lifters worked because of ionic wind. Now, that's neat. That is super cool. I mean, hey, to build a drone that flies effectively silently, that would be pretty cool. It certainly has its place, but he put it aside as a curiosity. Now watching my video, he too went back to ask an awful lot of questions for which he didn't have answers. Because he was an old friend and because he was interested, we dialogued extensively, and I shared with him so much more about the discoveries I had made that I alluded to in that first video but did not say. I was trying to walk everyone through the process of the discovery I had had, right? You know, what I learned, how and why, and I had every intention of continuing on with that and explaining all of these other, probably dozens of little points of discovery, of which most of them were discovered by accident. So he started conducting research as well, both trying to replicate my experiments, and he did some brilliant thinking out of the box and came up with even more experiments that were really complementary to my research. And at the same time, we were making all of these fascinating discoveries and observing often bizarre effects that I still cannot explain. We kept joking that we could write an entire issue of the Journal of Irreproducible Results just from our research. It was a continuous string of bizarre and unexplainable effects and observations. However, commercial applications of our discoveries quickly became evident. And we had been funding this research out of our own pockets, of course. So my friend, who shall remain nameless for the moment, went to the owner of the business for which he does a lot of research and development. And the owner and that business and that country shall remain nameless for the moment. Before you knew it, we had financial backing to pursue all of this research. That, of course, meant I had to stop talking about it. So now here we are, almost 2 years after I posted that video in Pursuit of Antigravity Part 1. I am proud to say we now have a patent pending as a direct result of that research. And that patent is probably only the first of many, because as I'm about to carefully share, this went in so many directions that I did not expect, and almost every single one of those directions had immediate commercial value. Also, in the meantime, you guys pumped up the viewership of that video to where it's currently at, what, around 11,000 views? And a whole pile of fascinating comments and questions, some of which I wish to answer and discuss in this video. So please be patient with my tempered responses. As you'll understand, I'm walking a fine line here of sharing as much as I can with you guys without giving away trade secrets that a company just spent a whole pile of money on to support us in obtaining through what has been incredibly fun and fascinating research. And if the patent goes through and we can develop commercial products, then we'll have more funding with which to pursue the other lines of research. For example, at the time of making that video, I was also simultaneously pursuing several lines of research that were related to the lifters and potential anti-gravity. For example, I am still working on a solid-state gravity detector. Now, the implications of such a device are huge. Several years ago, I tried my hand at mapping gravitational anomalies across 1,800 kilometers of Ontario here in Canada. And I learned pretty quickly just how difficult it was to measure variations in gravity. It could be done, but it was tricky because the variations were just so small. So now, when it comes to research where I'm potentially generating a gravity field or a gravity well, the ability to measure point gravity is really useful. For example, I can now, map the shape of a gravity field and get a solid measurement on the effects of changes to the gravity generator, right? Or use such a detector for a feedback loop on a Half-Life 2 gravity gun or whatever. The industrial, commercial, and scientific applications are endless. And such a sensor would be invaluable if you are trying to generate a gravity or anti-gravity field. Now, Andres Pereda, I hope I said your name right, sorry if I didn't, posted a very good question about the dielectric. Taking lessons from a capacitor, he suggested that if you swap out the dielectric for something with a higher K factor, would that increase the force generated by an asymmetric capacitor? Excellent question, Andres, and this was a huge avenue of research I had already followed before my friend got involved. In fact, T.T. Brown emphasized this over and over again in his papers as a major line of research towards developing this anti-gravity or electrogravitics. So that everyone understands what we're talking about, remembering that a capacitor, it's an electronic component which is simply two plates separated by an insulator. In electronics, these two plates are virtually identical in size. In our gravity generator, the whole point of discovery here was T.T. Brown, as a 16-year-old boy, discovered that if you have a capacitor with one plate smaller than the other in surface area, it's asymmetric. And if you charge it with a high voltage, it produces this mystery force in the direction of the smaller plate. So the insulator and the capacitor can be just about anything that insulates. And in the case of my experiments with the lifter, I was using air as the dielectric. All insulators have a dielectric constant represented by the letter K. Air has a dielectric K of about 1. And if you look at this chart produced by Honeywell, you can see the K values of hundreds of materials. Interestingly, water has a very high K value, but as you can see, most materials have a K of 2 to 5 typically. Some have very high K values in the 20s or even 59, which is considered very high. So if I make a capacitor that has an insulator and say it has a capacitance of 10 microfarads, and I replace the air with ABS plastic, which has a K of around 2 or twice that of air, I will literally double the capacitance of the capacitor merely by swapping out the insulator. So if I were to use, say, acetamide, which at room temperature has a K of over 40, that same capacitor will have a capacitance of over 400 microfarads. So Andres proposed that by using a different dielectric in the asymmetric capacitor, will it also increase the thrust? The short answer is yes, but it gets really complicated really quick. And this is where I had already put in a pile of research, because you can easily get materials which have a very high K value. Titanium oxide or titanium dioxide, for example, which typically have K values approaching 100. And where do you get titanium oxide? It's the most common white pigment used in paint and cosmetics. So literally, go down to your hardware store and spray paint your asymmetric capacitor with white paint, and you have just added a very high dielectric to the mix. Add dozens of coats, and each coat increases the thickness of the dielectric. Now, then you have materials like barium titanate with a K value over 7,000, or calcium copper titanate, which has K values of over 10,000. Now, the problem with these materials, they're ceramics. So to apply them to your lifter, you have to fire them at extremely high temperatures or bind them with a glue of some sort. Using the glue drastically reduces the K value because your glues always have a low K value. And now you're mixing materials of extremely different K values together, right? However, I came across this research paper from 1929 where they were getting K values of 18,000 from Rochelle Salts crystals. Now, Rochelle salt crystals are easily grown. As a matter of fact, a lot of homeschoolers use them as a science fair project because you can use materials found in your kitchen. Cream of tartar and baking soda. You can grow these crystals easily in your home lab. The crystals are especially fun because they are also piezoelectric. So if you tap them, they generate electricity. And you can even generate electric sparks in a dark room if you hit them hard. So don't get me started on the rabbit trails that the piezoelectrics caused. more rabbit trails. However, this brings me to a couple of other comments you guys made. So the True Man Zoo and the Human Race both suggested experimenting with shaping of the electrodes in the asymmetric capacitor, which I had already experimented with, and many of you guys making these lifters had also experimented with. So I will simply defer to what others on JLN Labs reported, for example. My research was inspired by Dr. Paul Laviolette's comments on the B-2 stealth bomber, and specifically its shape. But not just the shape of the electrodes, but the shape of the dielectric as well. So this is what led us to researching how to make complex shapes with these complex dielectrics. For example, in that 1929 paper on the Rochelle salt crystals, you'll notice that they cut the crystals along different axes and found that the K value changed drastically depending on which axis you cut. Then there's the question of, do you polarize it while the crystal is growing? Does it retain its polarity over time? Does the polarity have an effect on the force generated by the asymmetric capacitor? So we developed several ways of creating shaped dielectrics and even polarizing them while they were created, which I won't share the technical details of here, nor the results of our research, except for one point which we discovered the hard way with the Rochelle salts. It's true, the K value was through the roof. I made an experimental capacitor where you could easily swap out the dielectric to measure the K value of different materials. The Rochelle salts produced capacitance values that forced me to modify my test bed because the values were literally off the scale. I would zero the scale using air as a dielectric. And then I couldn't measure the dielectric of the Rochelle salt crystals because it was too high. But the real problem surfaced in that we discovered that the Rochelle salt crystals effectively made a zener diode with a very low threshold voltage. Now, I forget, it was like 2.5 volts or 3 volts or something. So what would happen is it would clamp our voltage, and we couldn't apply high voltage across our lifter that we needed for our thruster to work. But here we go again with offshoot research that I have to be careful what I share, because we developed ways of rapid crystal growth and shaping. This could be applied to supercapacitor manufacturing, or at least that's the way I see it. That's one application. Most supercapacitors have a very low maximum operating voltage anyway, typically 2.5 volts. So that's a rabbit trail I would like to pursue. Titanium oxide is also the pigment used in white 3D printing filament. So while it's not the best dielectric, we could literally 3D print a dielectric in any shape we needed. But it wouldn't be polarized. It's using a glue to bind the titanium oxide, but it was still much higher dielectric than air, and it was shaped. So a ton of viewers commented on the lifters working or not working in a vacuum, and that this was a very important line of research. I wholeheartedly agree, and that is exactly why I custom built a very large non-conductive vacuum chamber with a clear window for filming, force measuring gear, and bulkhead connectors with which to connect sensors, and of course the high voltage needed to run the experiments. Nomad Prospector implied he actually conducted vacuum chamber experiments which showed his lifter didn't work. And in fact, it sounds like he has a hilarious story with that about not using a fish aquarium for vacuum chamber. Yeah, I agree. That brings pictures to mind. That sounds like it would be a nasty explosion or implosion. Regardless, let us not forget that experiments conducted at multiple facilities over the past several decades have demonstrated that yes, these devices do generate a thrust in a vacuum. Jean-Louis Naudin, JLN Labs, posted a video of one of these experiments conducted in 2003 by Gravitic Inc. at NASA's LEAF facility. It was of paramount importance to me to conduct vacuum chamber tests because everybody, including myself, including my research partner, even including the Mythbusters, we had all at some point concluded that the lifters were operating merely on ionic wind. So if you remove the air, no more wind. Therefore, whatever force you are left with has nothing to do with ionic wind. So I took one of my triangle-shaped lifters, stuck it in the vacuum chamber, and sucked it down. Now, one of the best things you can do in science is make a prediction, right? So my research partner made a prediction. He predicted that with the increase in vacuum, the thrust would dwindle down to 0. I predicted the thrust would drop by 1/3 compared to what it produces at atmospheric pressure. I won't tell you how or why I came up with that very specific number, except that it was based on the dozens of hours of research I had been conducting. So I fired up the vacuum pump and would charge the lifter every few minutes and measure the force it was producing as the vacuum increased. It completely defied our predictions and expectations, in that the thrust it produced didn't decrease, it increased, and dramatically so. Now, he and I are still debating on why it did it. And at this point in time, I think we would agree to disagree, and that more research needs to be conducted to determine who is right and why, because we're both sticking to our guns. However, some of you will already see where I'm going next with this, and in fact, a couple people even brought this up in the comments. I could only get the vacuum down so low. Now, because it's counterintuitive, but air at a lower atmospheric pressure actually has a lower breakdown voltage. So the moment I got the chamber down to about 0.5 bar, a plasma arc would jump between the exciter wire and the collector plate.
So pretty.
Now, it was quite pretty, but the instant that plasma flared up, it would instantly carbonize the balsa wood frame of my lifter. The carbon turned my balsa frame from an insulator into a resistor, and my lifter was instantly ruined because now, even at atmospheric pressure, the carbon acted as a resistor, conducting the high voltages. I literally had to build a new lifter, which I then promptly destroyed in the vacuum chamber in the exact same way. Then I switched to using plastic straws for the frame. Now, this helped, but you still have the problem with the plasma formation until you get a very hard vacuum in the chamber. I couldn't get a vacuum down enough, and I haven't been able to get back to that research because my personal life has taken many twists and turns the past couple of years. However, this led to still yet more offshoot research where I was trying to make plasma to generate some effects. So currently I'm looking at developing a new and improved plasma thruster for use in spacecraft, for example, and also a nuclear fusion reactor, which produces no radioactive waste and through a couple of different techniques may produce electricity directly from the nuclear fusion taking place in the plasma. There's been a ton of YouTubers who have built home fusion reactors, which are seriously cool, like the Plasma Channel, but also very, very dangerous because they produce some seriously nasty radiation. On that note, in terms of safety, please note that both my research partner and myself have been using a Geiger counter on occasion when conducting our research, mostly checking for X-ray radiation. I mean, we're using high voltages and we're observing very, very bizarre reactions. So who knows what else is going on. So if you're doing this at home, be checking for things like X-ray radiation. Back in my early 20s, I probably shot X-ray beams right through my brain when I was making a binocular headset using 2 cathode ray tubes. The problem was I was unknowingly running them way over voltage. So CRTs are already bad for that. They can produce X-rays under normal operation. But now you run them 25% over voltage? Well, let's just say that they gave me X-ray vision, but not in the way you would think. So in the case of the plasma in the chamber or the lifters in open air, so far we have not had any detectable radiation of any kind, except of course for a whole lot of EMP. However, on that note, Wolfstein made an interesting suggestion on YouTube. Run the GPS program on your cell phone, place it near the experiment. If you're actually generating gravity, it should interfere with the GPS signal. This is actually a very interesting concept, and I was checking for that using 2 stopwatches because gravity alters time, which is why GPS satellites have a slower running clock on board because they need to keep precise time with clocks on Earth. But the lower gravity the satellites are in makes the clocks run faster because time is running faster there, where the gravity field is weaker. So, the problem I discovered would also apply to your quite brilliant idea there, Wolfstein. The problem was that the high voltages mess with nearby electronics. It will have an alternating frequency to it. And the first time I ran the stopwatch experiments, I got super excited because I came back after letting it run for an hour or so, only to see that the stopwatches were out of synchronization by hours. And the problem is further complicated when you electromagnetically shield any nearby electronics. Because as I also quickly discovered, electromagnetic shielding may actually double as gravity field shielding. So, I don't know that for sure yet. And I can't tell you why I have that suspicion, but it is something to ponder. It was actually a super genius friend of mine who suggested this. For example, he just said, hey, metals conduct electricity and heat. So who is to say it is not also a conductor of gravity? Anyway, it turns out the EMP the gravity cell was generating and putting out, it was basically resetting the time and date on the stopwatch that was close to it. I had to watch it, and sporadically the time and date would jump to random settings. So also, after doing some more research into time dilation, it turned out that the dilation was exceedingly small, so that even if I was generating a very powerful gravity field, it would probably take experiments that were at least, months long before I was able to see a difference in time between control clocks and experimental clocks. The Voyager space probe, for example, is still communicating with Earth from deep space, way outside of gravitational fields, yet it is transmitting within the bandwidth of the designed radio frequency. So I instead decided to focus on researching the solid state gravity detectors. However, an offshoot of this was using my Geiger counter and putting some radioactive rocks, literally, right on top of my anti-gravity cell and powering up the anti-gravity cell. I have some good old Canadian Shield rocks, which are pretty hot radioactively, right? So if the cell is producing genuine gravity, then it will be dilating time, and the half-life of the radioactive elements should also be altered, and quite possibly that detection rate detectable as a change of radiation emission rates. In other words, the isotope's half-life should also change. So this is another area I'm still researching. I had problems with my Geiger counter at that time that I didn't know about, so I'll get back to it. Another research rabbit trail, which ties in with all of this, is methods of gravitational shielding. This has been an area of research for a number of labs around the world and becomes important if you're trying to generate gravity, right? All right, so I've already droned on way too long here. Sorry, gang. I wanted to give you guys an update and also thank you for your excellent comments and questions, most of which I haven't been able to get to because either I can't answer them because of proprietary concerns regarding our patent or just because of time. Hopefully, I've given you a taste for some of the answers, and hopefully you'll stay tuned as I hope to put up more videos on this specific topic in the future. So, have a great day, ladies and gents.